Hello students, welcome to my class of engineering mechanics. Today I will give you the lesson about friction. This is the very first chapter in your curriculum of this subject. So now, what is friction? Friction is a force between two surfaces that are sliding or trying to slide across one another. For example, when you try to push a toy car along the floor, okay, so friction always works in the direction opposite from the direction of the motion of the subject. It always parallel to the plane of contact. Here you can see a kid moving through a bicycle, and the friction is uh, directed as the opposite side of the moving. Okay, what are the reasons of friction? The major cause of the friction is the interlocking of minute projection on the surfaces, which opposes the relative motion. This is the pictorial view. Okay, okay. This is the pictorial view of the friction. A body is resting on the ground, and W force is acting on it. This is the self weight of the body, and if you apply P force on the body will move in this direction, but the friction will acts in the opposite of the moving its direction. The amount of friction depends on the material from which the two surfaces are made. The rougher the surface, the more friction will be produced. Here, what are the types of friction? Okay, friction normally broadly classified as two types. Number one is dry friction, and number two is fluid friction. Now, what is dry friction? Dry friction is a force that opposes the relative lateral motion of two solid surfaces in contact. Okay, so here goes the dry friction. And what is fluid friction? Fluid friction is the force that resists motion either within the fluid itself or of another medium moving through the fluid. Okay, so that will fluid friction. Now, dry friction broadly classified as two part. Number one is static friction, and number two is dynamic friction. Now, what is static friction? Static friction is a force that keeps an object at rest. That means in case of static friction, no movement will be allowed. It can be also defined as the friction experienced when individual try to move a stationary object on a surface without actually triggering any relative motion between the body and the surface which it is on. Okay, and the dynamic friction is also called as kinematic friction or rolling friction, sliding friction, etc. Okay, so dynamic friction or kinematic friction occurs when two objects are moving relative to each other and rub together. Rub like means like a sled on the ground. Okay, you can sled on the ground, that is dynamic friction. Dynamic friction also classified at two parts. Number one is sliding friction, and number two is rolling friction. Now, there are some key points that you should know about friction. That is the resistance offered by the surface due to irregularities, of course, against motion of a body by the system of moving the system to the moving the system. Okay, and you all have to know what is viscosity. What is viscosity? In fluid mechanics, resistance offered by the fluid within the system layer to layer itself is known as viscosity. And due to the frictional force, our effort to do particular work is being increased. Friction must be Friction is must for the operation of belt, clutch, screw jack, brake, automobile, etc. Okay. Remember one thing, in case of bearing, friction is very much undesirable. So in bearing, we don't want any friction. Okay. The power loss due to friction is converted into heat. The power which is lost by the friction is converted to heat. These are the laws of dry friction. As I told earlier, what is dry friction? This is a two block, A block, and the self weight of the block is W, that is acts downwards, and this is the normal force. Okay, and this is the surface contact. The maximum static friction force and kinematic friction force are proportional to normal force. Okay, and it's dependent on the type of the condition of the contact surface and independent of contact area. That means whatever your contact area is, this is there is no relation between uh, in the contact area. Here is a graphical view of force and P. That is, this portion is equilibrium, this is a linear portion, straight line, and after that equilibrium portion the motion comes through. Okay, these are the some coefficient of friction. You can see the approximate values of coefficient of static friction for dry surfaces are different for different kinds of material, like in case of metal of on metal, metal on wood, metal on stone, the values are different for each cases. For example, in case of metal on metal, the values come 0.15 to 0.60. In case of metal on wood, it's 0.20 to 0.60, and etc. From stone on stone to 0.40 to 0.70. In case of earth on earth is 0.20 to 1.0. Okay, so these are the two numerical expression, that is maximum static friction force, that is Fm. Okay, that is normal force. N mu s is the friction for static. Okay, and kinematic friction force mu k is the coefficient of friction for case of kinematic, and it is written as mk is approximately 0.75 mu s. Now, what is the friction versus applied forces? Okay, there are four situations when a rigid body is in contact with a horizontal surface. Four cases can be there. Number one case, if there is no friction, means when you apply the load. This is a block, wooden block, say wooden block, its self weight is W, and you put a load of P is directly vertical to this body, so there is no horizontal component, right? So there will be no friction as Px equal to 0. Now the next figure, in this wooden block the self weight is same as W, and you put a load P inclined to this manner, right? So the P force has two components, that is Px in the horizontal direction and Py in the vertical direction. So for this Px load, for this Px component, there will be a horizontal force. Okay, so if the frictional force is greater than this Px horizontal, so no motion will be there. There will be some horizontal forces, but no motion will be there as the friction force is larger than this Px force. Now the third case, you applied a P load. Okay, the P load has two components, Py and Px. Px is in the horizontal direction and Py in the vertical direction. And if this Px horizontal force is equal to your frictional force, then motion will be just impending. Okay, so in this case, if Px is equal to Fm, then motion will be impend just. And the last case, if this P force applied inclinedly, same manner previously, so there will be two components, Py and Px, and this Px, if this Px is greater than your frictional force, then motion will be applied as this force has two components, Px and Py in the vertical direction and Px in the horizontal direction, and your frictional force will be act in the opposite direction of the force, and Fk, that means this frictional force is less than this Px force, so obviously this horizontal force will tend to start the body to move in this direction, so there will be a motion. Now what is the angle of friction? It is sometimes convenient to replace normal force N and frictional force F by their resultant R. Okay, so these are So what is angle of friction? It is sometimes convenient to replace normal force N and friction force F by the resultant R. One second. So in this case you can see no friction is there, okay, as the P force is directly acting on this body, is a wooden block, so there is no friction. This force is directly vertical, okay, and if this force is inclined motion, there will be two component, that is Px and Py, and there will be also no motion, as we assume that the P force, that means the horizontal direction Px force, is equal to your frictional force, so there will be no motion as previous. So here is a term, that is phi s. This phi s is angle of repose, okay, so we can calculate the angle of repose value, that tan of phi s equal to Fm by n. What is your Fm? That means this F value divided by your normal value, okay. In this case, this, if this is phi s, then this is the Fm and this is m, so you can get the tan phi s value, and you can see Fm is equal to mu s into n, so n cut it down, so tan phi s is equal to mu s, okay. And in this case is motion is just impending, as Fm is equal to Px, and in this case motion is already has started, as this Px value is greater than the frictional value. So in this case tan phi k, and this is kinematic friction, coefficient of friction, tan phi k is equal to Fk divided by n, and Fk is written as mu k into n, so n cut it down, so tan phi k is equal to mu k. Clear? Now this is the friction in inclined plane, okay. So consider block of weight W resting on a board with variable inclination angle alpha theta. So in this case no friction will be there. In this case also no motion is there, as your F value is equal to this horizontal thrust value, and here motion is just impending, and here is motion also started, okay. In this case, when motion is just impending or motion impended, so your theta value will be is equal to phi s. That means your angle, this angle will equal to the angle of repose. Now these are the problems involving into dry friction. What are the problems we have faced? That all applied forces are known, coefficient of static friction is known. We have to determine whether the body will remain at rest or slide. In this case, all applied forces are known, motion is impending, and determine the values of coefficient of static friction. And in this case, senses of impending motion, you can see coefficient of static friction is known, motion is impending. We have to determine the magnitude or the direction of one of the applied forces. Here are the some problems. You can see a 500 Newton force acts as this figure, in this figure, 1.5 kilonewton block placed on an inclined plane. The coefficient of friction between the block and plane is mu s is equal to 0.25. Your static coefficient of friction is 0.25, and your kinematic coefficient of friction is 0.20. So we have to determine whether the block in equilibrium, and in the we have to find out the values of the friction forces. So we have to calculate the maximum friction force and compare with friction force required for the equilibrium. If it is greater, block will not slide, and if maximum friction force is less than friction force required for equilibrium, block will obviously slide. So you have to calculate the kinematic friction force. So this is the solution of the problem. You can see by this summation of fx equal to 0, this is the equilibrium condition. You can find out the F value. Now here the F value comes negative, negative minus 500 Newton. So what the negative value implies? Negative sign indicates our assumed direction is wrong. Okay, hence the reverse direction of the force. So Fy is equal to 0. These are the two equilibrium condition. So from there we can find out our normal end force, that is 1500 Newton. We all know the maximum friction formula is Fm equal to mu s into n. So our mu s value is 0.25 as it is given. Our static coefficient of friction is 0.25. So Fm is equal to 0.25 into 1500 Newton. That means comes 375 Newton. So the block will slide down the plane, right? This is the graphical representation of the problem. We have to then find out the actual friction. What is the actual friction? Is equal to uh, coefficient of kinetic friction into our this value, this n value, 1500. Okay, so 0.20 into 1500 Newton. So F actual is equal to 300 Newton. Clear? This is the maximum value and our actual value is 300 Newton. Here are another problem. Okay, these are the solution, and there is problem 3. This is the solution, and this is problem 4, and here is the solution. Okay, at the end of this lesson I will share the PPT so that you can go through this, the numerical problems thoroughly and practice yourself. Okay, thank you. That's all for today. Now in the next class I will go through another chapter.